Good afternoon, everyone, and welcome to the fourth in our series with the BOHS and the UK Hearing Conservation Association. Hello to those of you who have already been on one of our webinars over the last month and a half or so, and welcome to anyone for who this is their first webinar. So the running for today is we've got Claire Forshaw, who will give a brief overview, for those of you who haven't heard it, about the UK HCA and what they do, and then she'll pass you over to Emma and Mark for our presentation today on is your hearing protection protecting. So as some of you may know, we do a Q&A session at the end of these. So if you've got any questions, you should have your Q&A box on the right hand side. So just you can put your questions in as we go, or you can wait until the end and we'll pose it to our panelists today. Any questions we don't get to, we will post them afterwards, and we'll send it out in an email along with the recording of the webinar either tonight or most likely tomorrow morning. So that's my little amble over and done with. So I'll pass you over to Claire and hope you all enjoy the webinar.
That's great. Thanks very much, Lee. Yeah, thanks for joining us, and thanks particularly to our two speakers today. As a lot of you know, we've been running a series of these presentations, webinars over the past few weeks. So much thanks to BOHS for hosting us and giving us the platform to give these presentations. I'm going to do a very quick introduction because I think most of you have probably heard this before, but who are we in terms of the UK Hearing Conservation Association? Well, we're basically a kind of group of passionate and like-minded people who've come together to form this association as a charitable organisation for providing independent but credible advice on conserving hearing in various scenarios and aspects of life. So basically our kind of membership is formed from various people, so who've come together to protect people's hearing and prevent avoidable harm, and we're made up of health and safety professionals, occupational hygienists, occupational health professionals, acousticians, manufacturers and suppliers, as well as charities, professional bodies and trade bodies as well. And this is basically our kind of mission statement. We are passionate about preserving and promoting the protection of our nation's hearing health. And what we've got there outlined is our key working groups. So we've got special interest groups who are developing materials, advice and activities around hearing conservation in the workplace, hearing conservation at leisure. An important aspect of what we do is trying to reach out and educate young people, because we feel that's where we're going to have the biggest gains, because they're going to be our future workforce, our future, people who will can change attitudes, if you like, and we can help them change their attitudes to having a more healthy relationship with noise. And another important area for us is hearing conservation in music and entertainment and those kind of sectors. And again, that's really important because it's quite different to unwanted noise that we're used to in workplaces. They're creating noise and sound for entertainment. So it's quite a difficult area to influence and change. The one that's not on that slide is in design. Again, we feel it's really important to try to influence from where the most gains can be made, I guess, in looking at acoustics and designing for good noise control, and also designing for people who may already be hearing impaired, so for good acoustics, so we don't have to turn things up and make things louder, as well as protecting people who already have a hearing loss. So that's something we had a presentation on a couple of weeks back, which you can look up if you missed out on that one. But that's another area of our interest. Noise is a bit of a Cinderella topic. I guess most of you on the call will be occupational hygienists, and you're probably used to dealing with dusts and fumes, substances and the like. Physical agents generally get less of our attention, and I think noise is one of those always there issues that we find a bit more difficult, and a lot of what we'll do to manage noise in workplaces is to provide hearing protection. So I think we'll hear a lot of really interesting facts and information today about how we can do that better and the pitfalls to be aware of and to be careful of when we do kind of rely on hearing protection as our key control measure. Because it's not just about hearing loss. I mean, obviously we're quite used to noise being associated with hearing impairment, things like tinnitus, but we also have to remember that it has a huge impact on cognitive ability, on communications, on relationships. It's a stressor, so it can cause stress to people. So it goes much more beyond just preventing people from losing their hearing ability. So yeah, I only wanted to give a quick introduction, so hopefully that gives a bit of background as to what we're about. And again, really pleased that Emma and Mark can join us today. The next one in a couple of weeks is managing reproduced sound in office and industrial environments. So hopefully, if you want to join us for our last in the series, that's the one coming up in a couple of weeks. But beyond that, do keep in touch with us. We produce a newsletter every 3 months, so it'd be great if you could sign up to that to keep in touch with a lot of the information like what we present in our webinars. And if I quickly introduce Mark and Emma, our guest speakers for today. Emma I know very well because I've worked with her for many years. Emma's a noise and hand-arm vibration senior scientist at in old money HSL, now known as HSE's Science and Research Centre over in Buxton. Her work includes conducting bespoke research for HSE, providing the evidence base for their guidance and policy positions, doing work for the private sector, including military applications, and providing subject matter expertise to UK and European standards committees on hearing protection. Mark is a registered hearing aid dispenser and a supporter and advocate for the UK Hearing Conservation Association. He's a member of the Institute of Acoustics. He's passionate about helping people to conserve their hearing, and his work centres on developing products that help prevent noise-induced hearing loss by developing accessible tests that people can use to make informed choices regarding their hearing health. So without further ado, I will hand over to our speakers who have organised between themselves how they're delivering this presentation. So thanks very much, and I hope you all enjoy the session today.
Thank you.
Thank you for that, Claire. I'm just going to pass presenter rights over to you now, Emma. So you should be able to share your screen.
Marvellous, thank you very much. Now I just have to remember how to do it. There we go, and we shall have that one. There we are. Hopefully you can see that one.
Thumbs up from here, and I'll mute myself again.
That's great. Thank you very much. Well, thank you very much for that introduction, Claire, and thank you for tech support, Lee. Mark and I actually know each other from the Hearing Protection Standards Committee, so we've got to know each other a little bit over the past year, haven't we, Mark?
We have, yeah.
So, yeah, what are we talking about today? Well, is your hearing protection protecting? Just made a note on a couple of things that Claire said there, which we might come back to later on and might well appear in the questions. So, what are our aims for this session? What we would like to do is hopefully you go away with some information, but we're going to try and hopefully give you an understanding of hearing protection performance, how it can vary, why it varies, and how not to select hearing protection, how to and how not, and how hearing protection can work for you. And we realise that we have possibly an educated audience to some degree on the line with us. So forgive us if we tell you anything you know, but hopefully you'll go away with something. So that's our aims, therefore we must have some objectives. And the objectives are essentially the contents of what we're going to talk about today. So Mark and I are going to do a bit of a double-handed, double-act thing where we hand backwards and forwards. But these are kind of the topic areas that we're going to cover in today's session. So starting with hearing health, which is clearly something that all of us involved here are passionate about, with Mark and I coming at it from different aspects, but it's something we certainly agree on that is important, and Mark's going to elaborate on that a little bit more. And then as you can see, we'll move through some of the other topics. It might not necessarily be that that's how you would approach things in that order, but hopefully it will all make sense and you'll come out perhaps with just a nugget. That would be great. So at this point, I would like to hand over to Mark.
Emma, thank you. Okay, so I'm going to start by talking about hearing health. Our hearing health is something most of us take for granted, I think, until it starts to cause us problems. And it's something that we really have to experience to fully understand how vital it is for our general well-being. Noise-induced hearing loss progresses very slowly. It doesn't hurt, it's not life-threatening, and day to day people don't notice they've got it. It can be difficult for that reason to get it across to people, because each day you wake up with apparently the same hearing as you had the day before, so it just sort of very gently creeps up. Studies show that people spend an average of 7 to 10 years in denial with regards to a hearing loss. And in fact, I think we've all met those. They're people who are convinced that everybody matters. In extreme instances, they become convinced that BBC newsreaders can't speak the Queen's English. And then they finally come around to the idea that they probably need to get some help. Just as an aside, I spent about 10 years or so dispensing private hearing aids, and I've seen many people who were seeking help for the first time, possibly dragged in by a partner. They didn't even really want to be there, and they were convinced their hearing wasn't too bad. That was the phrase they'd usually use. Upon measuring their hearing, it would turn out that they'd have the kind of hearing pattern that would have absolutely terrified them if they'd woken up with that in the morning, having had normal hearing the day before. It's very surprising how your perspective on that can desert you. Claire actually very eloquently described some of the effects of hearing loss, so I'll pass over that one because she's already talked about it. People deal with hearing loss differently. So some people withdraw from social situations, and we've all seen those as well. They're people who sit in the corner hoping that they're nodding in the right place and not offending anybody. And some people talk a lot, and that's a common strategy because then you don't have to listen to what people are saying. It eventually does become apparent in the case of noise-induced hearing loss that hearing aids are probably the best solution. But not many people want to wear hearing aids, and although the results are usually fantastic if they do take that step, they're seen as quite expensive for most people if private, and a little less than convenient if NHS. I probably should stress at this point that I'm talking specifically about noise-induced hearing loss here, which of course is irreversible. There are other kinds of hearing loss. Some of them are treatable, but we don't really have the time to go through those. But I should say that if anybody experiences one-sided hearing loss, sudden hearing loss, or one-sided tinnitus, i.e. noises in the ear, that should be investigated as a matter of urgency. That may or may not be connected with noise-induced hearing loss. The slide on the right is from a recent piece of research published in The Lancet. That confirms that the single biggest modifiable factor in our lives to help manage early onset dementia is treating hearing loss. There have been rumblings about links between hearing loss and dementia for some time, but this particular study is well researched, and it really does raise the bar significantly in terms of thinking about how we approach, or how much importance we attach to hearing. So why am I telling you all of this? The reason is that a major contributory factor to hearing loss after aging is excessive noise exposure. And whilst we can't do anything about aging, we can help to prevent noise-induced hearing loss by using hearing protection. Emma, thank you.
When Mark and I were putting this slide deck together, one of the descriptions you used for the image on the left there, Mark, was, I think you said, that's how we all want to look when we get to our retirement age, the happy pensioner.
Yeah, I did.
And certainly I'm all for that, definitely. So that brings us, apologies. So that brings us to now, are you sitting comfortably? This is the good bit, hearing protection regulations. So I'm very safely on home turf here, and hopefully won't lose any of you at any point through this. But just so we understand what it is we're talking about in terms of how hearing protection and the regulations relate to one another, and which regulations as well. That's kind of good to know. So the first point I'd like to talk about is that we do have the control of noise at work regulations, under which there is a requirement to protect workers' hearing. I'm not going to go through all the text. You can read that for yourselves in HSE's document L108. But what it does say in there is that if somebody's daily personal noise exposure, which is that LEPD thing that's on the screen there, I don't want you to get too het up about that, but that's a time-weighted average noise exposure. If an individual's noise exposure is between what's called the lower exposure action value and the upper exposure action value, then certain duties kick in, and one of those is that suitable hearing protection must be available upon request. And I've just put a little note in there to just remind us all as well that there's also an LC peak action value related to that. So it's not just the time-weighted average, it can also be one of those sudden instantaneous sounds. Similarly, or rather in addition, if somebody's daily personal noise exposure exceeds the upper exposure action value, or the LC peak exceeds the upper exposure action value, then suitable hearing protection must be provided. And it's this suitable thing that's kind of really important. There isn't a one size fits all. We don't all wear black, size 6 safety boots. I know I certainly don't. What else should we be aware of? Hearing protection has got a performance specification, and that's not just the performance of it in terms of the attenuation. It's also, does it catch fire? Does it break when it's dropped on the floor? Things like that. And all of those specs are covered in the Product Safety Standards Series for hearing protection, which is BSEN 352. And you may sometimes see that on packaging of hearing protection, because I know that you all read very carefully the packaging of hearing protection. It's like reading the instruction booklet for your new toy, isn't it? I urge you to read instructions, definitely. And then we have the PPE regulation. Now, this used to be known as the PPE directive. It changed, I think it was 2, possibly 3 years ago. Harmful noise was classified as what's called a category 2, and I won't go into the detail of what this all means. So you can, that's not what this session is about. But so you're aware that harmful noise has actually been upgraded to a category 3 item, which, as Mark let me know, it joins bullet wounds and drowning. And there was something else you told me as well, Mark, that it joins. I've forgotten what that was now.
Electrocution.
That was it, thank you. So it's up there with the stuff that can be seriously harmful, and quite possibly rightly so. What does that mean in terms of people using hearing protection? Actually, it doesn't affect the users at all, but what it does mean is that the manufacturers of hearing protection are required to do some more stuff than perhaps they were previously, and one of those things includes annual performance testing of their products. I've listed some of the source documents for that information there, so that you can go and have a look at those should you so wish. Now, talked about numbers on the packaging. Sometimes I think it's important to understand where some of these numbers come from. And the analogy I'm going to give you is thinking about your MPG of your car. So we have an MPG for our car, or we're perhaps going to look at buying a new one if we're in the fortunate position to do that. And it says it's going to do 65 miles to the gallon. And you know full well it's not going to do 65 miles to the gallon. It's more likely to do 43 miles to the gallon under the circumstances under which you're driving it. So I'd like you to bear that analogy in mind. So the numbers on the packaging, the numbers that tell you how much attenuation hearing protector will give, fall out of a standard test method, which is the one that's detailed here. And essentially what you have is octave band data across the frequency range. That's chunks of frequency split up in a technically acoustic way. I'm so technical when I talk about these things. And you use 16 what's called otologically normal people. So they have to have their audiograms within certain parameters in order for them to be considered otologically normal. And each one of those wears the hearing protector and is presented with test tones. It's pink noise in an anechoic chamber, and with and without their hearing protector in place. And the difference between with and without in place across those 16 subjects is averaged, and you get the hearing protection data. Now, from that information across that frequency range, the HM&L values, which stand for high, medium, and low frequency, and the SNR value, which is the one we're probably most familiar with, which is the single number rating, are calculated from that data. And that is also according to a standard test method. And this is what a piece of that attenuation information might look like. You may well have seen this on the side of boxes of those yellow earplugs, or perhaps those orange earplugs. Other colour earplugs are available. And As you can see, you've got the frequency bands of interest, the mean attenuation across those frequency bands, which is for those 16 subjects. And out of the bottom drops that APV, assumed protection value, and the HML and SNRs. Now, I just remind you once again that this is under laboratory conditions. This is a standard test. It gives us somewhere to start. This is like assuming that your car has got 65 miles to the gallon, and it will do that every single time. But it's not necessarily the case, and this is something we have to be aware of. Mark. Oh, hang on. Let's try that again. Oh, I've just realised what was on the bottom of that slide. Hang on, I forgot there was one thing on the bottom there, that we have a derating system in place, certainly within the UK and in other European countries, that is used to account for what we call the real world factors. But there are other ways of doing this, and Mark's going to talk about that. That was a better link, wasn't it?
Perfect, thank you.
Thank you.
Okay. Yeah, thank you, Emma. So fundamentally, the current method for putting out data as to how hearing protection works is based on the lab process, and the calculations that are done to define the level of attenuation, whether it's an assumed protection value, an SNR or an HML, are based on an average of 16 people. In use, as Emma mentioned earlier, it's well known that very frequently the hearing protection won't meet the specification. So the HSE recommend a derating value of 4 dB. There are various other studies that suggest either 5 or 6, but the message really is that the amount of attenuation as per the specification sheet probably isn't the amount of attenuation the person's actually going to get. It could even be more actually sometimes. There's a number of factors, there's a number of reasons for this. First of all, it might be a manufacturing thing. It might be that the piece, you know, if it's a custom made piece, it's either too big or it's too small or it's not long enough. It might in fact be more likely that in the instance of custom made equipment, the person isn't using it correctly. And if you have a look at the screen, you'll see that the guy on the left fitted his hearing protection perfectly, and the guy on the right didn't. They were part of a piece of research that we were doing, and neither of them were instructed on how to put the hearing pieces in, but they were both young, intelligent guys, and that just goes to show how regularly a person can get it wrong, really. Now, the same thing can happen with over-ear protection, in fact, although for different reasons. With over-ear protection, if the shape of the face is such that the cup doesn't completely cover the ear and there's, there's a bit of a hole here, say, then sound will leak a bit like water and they just won't work properly. Another thing could be a particularly small head, and the headband tension isn't good enough to clamp the cups to the person's ear. So what we've got then is a situation where there's a lab-based measurement. People are looking at the spec sheets and thinking that that's the amount of protection that's being provided, but in actual fact, it may not be. So the potential solution to this, of course, is to carry out a measurement at the person's ear, and that is a PAR, a personal attenuation rating. This is necessary also because, by definition, SNRs, etc., are for calculations for a group of people, and you can't apply that to an individual. And the PAR does provide a comparable measurement to SNR, except it's for an individual. I hope that makes some sense. So there are a number of ways of taking this measurement, objective ways, subjective ways, but it's a bit of a simplification, but fundamentally it uses the same principle. So in other words, you measure attenuation at various frequencies. You arrive at what's known as a personal sound attenuation level instead of an assumed protection value, and then you use the personal sound attenuation levels in a calculation which has been designed to produce a PAR, and then the PAR is comparable to SNR, except it's personalised. Now, the truth is, of course, that still has limitations because it measures the performance at a given time, but it's not monitoring the performance during the working day, so it's still not perfect. But I think it is a step up from sort of hoping that the spec sheet's right. The other thing that I'm very sure of is it's a really good check for checking whether the person's got the things in properly as a sort of a training tool. Because of course, if you do this test and return a ridiculously low PAR, then the chances are high that the piece isn't in properly. So that's a good training tool. Now, there isn't currently a legal requirement in the UK to carry out these checks, and there isn't a British or a European standard either that can be adhered to, you know, in the same way that an audiometry process can be adhered to. There is an American standard though, which was published a couple of years ago. So, you know, with luck, we'll follow them at some point, because I do personally feel that it's really important that this is formalised and people have a good expectation of what to expect from a PAR measurement. Thank you, Emma. that's me done on that slide.
Thank you, Mark. So that moves us on to factors for consideration in, you know, wearing, choosing, using hearing protection. I was just thinking then, Mark, about some of the things you were saying that affect how the hearing protection works. And I'm looking at myself on the screen here, and I'm a glasses wearer.
Yes.
So the over-the-head stuff, you know, if I put earmuffs on, I've got nice thick, oh, hang on, the screen's the other way around. Got nice thick arms on my glasses, which stand proud of the side of my head, and of course that breaks the seal. And
absolutely.
I really like the analogy with the water, because it's one of the things I say to some of our training inspectors sometimes is, do you remember your geography lessons when you're taught how water finds the path of least resistance to the sea from the mountains? Sound does exactly the same thing, doesn't it?
It certainly does, yeah.
Path of least resistance. Anyway, tell us about loudness of life.
Okay, I lifted this chart off the net, and what it purports to show is the level of noise of various things in our life. So I think, I can't really see that from here, but I'm pretty sure it says a pneumatic drill delivers 100 dB of noise. As Emma will explain, that's not a very helpful explanation actually of the true level of a pneumatic drill. And there are lots of different representations on the net. So I've seen pneumatic drills anywhere between 100 and 115 dB. I suppose it depends what kind of pneumatic drill they were measuring. But the point I really wanted to make with this is the absolute importance of having a noise survey done, as opposed to relying on something that you've lifted off the web that's probably the sound that, you know, your guy's listening to when he's using an angle grinder or something. That was it really. It was just to say that's, you know, not the greatest measure in the world.
You've reminded me of something there actually, Mark, which is when people look at doing their noise surveys and perhaps are doing the risk assessment for noise in the workplace, you can look at the instruction manuals and find, hopefully, some form of decibel number in those instructions. Unfortunately, those decibel numbers are taken from standard tests that often don't involve people and are at 1 meter away from that piece of machinery, which is of course not what that operator is experiencing at all, is it?
No.
So yeah, we need to know more information really, and I would encourage anyone that's in that position to challenge their challenge in a nice way their suppliers of machinery and actually find out that information. And that kind of leads into that noise exposure, which is the kind of that center image on the screen for you there. So a couple of things here to sort of point out is that noise exposure, which is that LEPD thing again, that's what you'll find in the control of noise at work regs, is about noise level, so what Mark was just talking about, and the time exposed. So we need to have both pieces of information in order to understand the potential harm to individuals and the people that are being exposed. what you hopefully can see on there as well, it might be slightly small, but down the left-hand side of that table, we've got some decibel numbers. And on the right-hand side, we've got some times. And this is to show the 3 dB exchange relationship between time exposed and how much that the level increases or how much the level decreases. I'm going to try and explain that a little better. That was a bit rubbish. Anyway, suffice to say, a 3 dB change, either increase or decrease, is the minimum that we perceive as human beings. If there is a 3 dB increase in the noise level, it's actually a doubling of the energy. And that's because decibels are this wonderful logarithmic scale, so they're not linear. And linear things are just much easier to deal with. Decibels are not linear. But that 3 dB increase we can only just hear. But if we have that 3 dB increase, for example, we're in 100 dB of noise, it's going to take 15 minutes before we hit the upper exposure action value. Well, let's increase that to 103 dB, and the time halves to reach that same upper exposure action value. So a barely perceptible by the human ear increase or decrease, and the time either halves or doubles depending on which way you're going on that scale. So yeah, a non-linear relationship, but in a kind of linear way. Mark, I think this is a good point for me to hand back to you on your hearing ability.
I think, I mean, the field of acoustics is sort of riddled with measurement uncertainty for people who know what they're talking about, and when you're trying to apply general principles, it becomes even less easy to explain. So I sympathise, but fundamentally, I hope that the point's made there. So we've talked about the amount of the protection that the person's wearing, the amount of attenuation it may or may not be providing, excuse me, the noise level that they're subjected to, and also the amount of time that they're subjected to it. But there is one other thing that also matters, actually, and that's their hearing ability. Because, of course, if you fit appropriate hearing protection to somebody with a normal hearing pattern, it will have a very different effect if you fit it to somebody who's got moderate hearing loss. And the effect that it will have on that person with the moderate hearing loss, probably, this is a bit of a generalization, but I hope it makes the point, what it will probably do is render them deaf in the workplace. And if you render them deaf in the workplace, then you put them in danger. They may not hear the forklift truck that's coming at them. So again, as we said, there are no legal requirements in connection with all of this. So at the moment, it's very much a question of how seriously people take it and how well they want to address the needs of their employees. But a perfect end-to-end solution, or start to end, or whatever it's called, would start with an audiogram to see what the person's hearing ability was. Thanks, that's all I wanted to say about that.
Could you perhaps just elaborate a little bit on that example there? Because we've got, I think, left ear, right ear. Is that two different occasions, that audiogram?
Yeah, so no, this was an audiogram. So fundamentally then, very quickly, we measure a person's hearing at a range of frequencies which are important for speech. And then we measure the quietest sound that the person can hear at each of those frequencies in each ear, which is then compared to what is considered to be a normal level. So you'll see that the right ear is represented by the red circles and the left ear is represented by the blue crosses. And if this person had had what is considered to be normal hearing, all of the readings would have been at or above the 20 line. So 0 dB isn't no sound, it's the quietest average sound a group of people could hear, otologically normal 21-year-olds years ago, which is why it goes to -10. And in practice, if a person picks up sounds anywhere between 0 and 20, they're highly unlikely to exhibit difficulty day to day. As soon as they require more than 20 dB in any of those key speech frequencies, they will then possibly start to exhibit some difficulty. But of course, the further away you move from 20, that means the more sound you need. And yes, the more difficulty you'll have. If you need 100 dB of sound before you can detect anything, then you have a really awful hearing problem, and a hearing aid has very little to work with. This particular individual, in fact, had an infection in their left ear, and as a result, their left ear readings were rather worse than their right ear readings. And that's interesting from a hearing protection point of view, because uniform hearing protection would have performed completely differently in each ear at the point at which this audiogram was current. I'm pleased to say that their hearing it wasn't mine, and their hearing did recover once the infection had gone.
Well, that's good to know that they did recover. It's quite a stark example of what can be seen, isn't it?
Yes, yeah.
Cool. So where does that take us on to? Let's think about selecting hearing protection. Mark, perhaps you could take us through this particular example.
Okay, so the first thing I should probably point out then is that this slide represents a gross simplification, and therefore isn't a very accurate way to select hearing protection, as we've put. But if you can forgive the lack of accuracy, I think it does make a point, or we hope it makes a point. The previous slide suggested that a pneumatic drill created 100 decibels of sound, and a quick look at the chart that Emma showed us suggests that 100 dB is safe for about 15 minutes. If you want to protect that person so that they can work in that noise for a period of time, then on the face of it, an SNR 15 would reduce the 100 dB by 15, thereby delivering 85 and enable the person to work for their 6-hour day. Hearing protection with an SNR 15 that is 5 dB under spec, and we've already established that that's highly likely to happen, actually, highly likely. Because of this 3 dB exchange that Emma was talking about earlier, that 5 dB change means there is a massive difference in the amount of safe time that the person can spend in the noise. We're now down to a little over 2 hours. And remember, that person thinks they're protected. If it is an SNR 15 device that's been badly fitted and a PAR process has shown they're only getting 6, and with that slide I showed you earlier, that's entirely possible, then we're down to an hour. And really, we hope that, although that's not in any way an accurate representation of the maths of the thing, what we hope is that that shows how vitally important it is that hearing protection is selected and worn properly. I think Emma's going to go on to show you how it should be done now.
Thank you, Mark. So what you saw on that previous slide is a really commonly seen way that people try and select a hearing protector. But because of the maths involved behind it, it doesn't actually quite work that way. So I'm going to just introduce you to the calculator that's available on the HSC website free of charge. And as I've been thinking about doing this, I've also sort of realized a couple of things that in terms of the influences on hearing protection, wearing and choice and so on and so forth, we can do this kind of calculation stuff. We also have to think about the work environment. Is it hot and sweaty, or is it really cold? Is that going to affect the materials of the hearing protector? And I'm not expecting everyone to be an absolute expert on hearing protection here, but it's things to bear in mind if you've got people in extreme environments. Also comfort. It's all fair enough us talking about all of this, but if people aren't comfortable wearing their hearing protection for whatever reason, if it's too hard, it's too big, it's too small, they're just not going to wear it. And then we haven't got anything at all, have we? So anyway, that was a couple of thoughts. I thought I'll just get them out there while I think about it. So in terms of actually doing hearing protection selection, I'm going to do what I hope, fingers crossed, will be a live example of a calculation. You might remember I had that information that I plucked off the web before from a previous, from a hearing protector. It had an SNR of 35, just in case you didn't spot that. And what I'm hopefully going to do is now share with you a different screen. And I'm going to show you. Oh, hello, where have we gone? What can you see, Mark?
Nothing at the moment. Well, us two at the moment.
Us two at the moment. There we go.
No.
What can you see now?
Yes, selecting hearing protection, a place to start with the HSE calculator.
Oh, don't you love it when the screen sharing is not going the way you intended it to go?
This is why I nominated you for it, Emma.
I know, I know. Where's Lee? Lee, come back.
I'm still here.
Why can't I not share this screen that I wanted to share? What's going on?
Do you have an option to share both screens? Or is it just the one screen?
If I share my screen, then I get that one back. And I want to share a different screen.
Are you able to maybe
Oh,
drag?
right. I've got it. I've got it. I've got it. I didn't have the right thing open. Try that. There we go.
There we go. That's different.
Thank you, everybody, for your patience with the slight technical incident. So we have the HSE calculator. This is a spreadsheet. You download it from the HSE website at the web address that was on the previous slide, which I now know how to get back to, which is useful. The example that we had on the previous slide that Mark used was using the SNR value. So what this spreadsheet does is it takes out all the horrible maths, and you only need a little bit, or you, the duty holder, only needs a little bit of information in order to actually make an assessment of whether the selected hearing protector is likely to provide adequate hearing protection. Bearing in mind, this is like from the data that has come from the laboratory testing. So we had an SNR of 35 dB, so I'm just going to type 35 dB in there. That's all we need to do, just fill in the white boxes. And then we're looking at what the C-weighted noise level is. Now, this is where the importance of having information about your particular workplace is important. And Mark alluded to spoke about the noise surveys earlier. The C-weighted noise level is not something we often talk about, but it is a parameter that can be measured. We often talk about the A-weighted noise level in a workplace. But this is the C-weight, and it's not the peak. The peak is something different. This is the time-weighted average, and if you're used to seeing acoustic parameters, it's the LCEQ. Now I'm going to make up an LCEQ for my workplace, and I'm going to say it's 89.3 dB. It's probably way too precise. We don't need that many decimal places. But assuming that's a C-weighted noise level in my workplace, I've chosen this hearing protector with an SNR of 35, which is quite a high SNR. And what happens is you get a result in this box at the bottom, and that result tells us that we are anticipating 58 dB at the ear. Now that is far too low a level at the ear. We're looking really between 70 and 80 at the ear under the hearing protector. And that should still maintain situational awareness and communication for the people wearing the hearing protector. And as you can see, that box is red, which means it's either under or over protecting, both of which are issues that we don't want any of our hearing protector wearers to experience. We had an SNR 15 hearing protector on our previous slide, so I wonder what that would do. I haven't tried this. This is a live experiment. Haven't tried doing this on the calculator yet. If we had a hearing protector that gave us an SNR of 15 in our particular workplace that has 89.3 C-weighted LEQ, then we get 78 dB at the end. And as you can see, that box has gone green, which means that would be a suitable hearing protector. Actually getting a low SNR hearing protector is quite tricky. And it's all wrapped up in how the hearing protection standards, that EN352 series we spoke about earlier, actually how they're laid out. And it's to do with the minimum attenuation requirements in there, which restricts actually how low effectively that SNR can go. That was the live demo. Glad that worked eventually. Just to draw your attention that you can also use the HML values, although there was me having a go the other day. And if you've got the octave band data for your workplace noise, then you can also use the octave band data. And there's full instructions on how to use that web page, or how to use that spreadsheet just there. So I shall take you back to the slide deck, which I think is going to be that one. There we go. That was much slicker that time, wasn't it?
Very good.
And I think that's going to pretty much bring us to the end of our session. Yes, it does. So there was one thing I was just thinking about there, Mark, as well, which I know that we've spoken about this week, was I know you were saying that there's no legal requirement to do the PAR, which is correct, there isn't, and there's no standardization as such for that yet. However, we're both part of a working group that's currently working on a document. It's a European document that lists or outlines the different systems for doing that. Is that correct? That's right, wasn't it?
Well, it outlines some different systems in existence. That's quite hard to say at the time that the document was written. So obviously, newer things are coming along all the time.
Absolutely, absolutely. So that brings us to the end of our short slide deck. That's kind of like a whistle-stop tour of hearing protection, why it does what it does and why it doesn't do what you think it's going to do, and all those sorts of things. So Lee, it's all yours.
Thank you very much for that, Mark, and a very interesting presentation there. And you'll be happy to know that we've got some questions in already. So while we run through these first few questions, we've got about 15 minutes left. If you want to throw any of your own questions, we'll get through as many as we can before people have to start going at roughly about 3 o'clock. So the first question is the 4 decibels just on SNR or applied to each frequency or HML level?
That's a brilliant question. I'm going to have to go and look at the calculator. I'm going to stop my screen share so you haven't got to look at all of that. So the D rating, no, it applies across all 3 methods. So on the calculator, it is across all 3 methods.
Thank you. And then the next question is, when engaging a contractor to conduct a noise sampling survey, what qualifications should they hold, or do they simply need to demonstrate a competency in sampling?
Who would like that one?
These are open questions, so
Well, I think if it was me, I would look for somebody on the MIOA website that specialises in noise surveys. I'm not actually sure whether there is a legal requirement to be qualified. Are you?
There's now I was having a conversation about this with one of our inspectors recently. There is I think in document L108, which is the HSE guidance on the control of noise at work, there is a phrase that says you want a competent person to do it, and how you determine that competency can sometimes be a little tricky. I'd agree with you, Mark, getting a provider who is an IOA member, possibly with the IOA qualifications, that they provide, now what's it, Certificate of Competence in Workplace Noise Exposure. That's one of the education offerings from the Institute of Acoustics, or indeed from somebody, an organisation that is registered with the Association of Noise Consultants, because they are often well placed to do stuff like that as well. I think from a regulatory perspective, the duty holder has to satisfy themselves that they've got somebody who knows what they're doing.
Yeah, and there's been some guidance put together that HSE, BOHS, IOA have kind of compiled to help duty holders select competence. But I agree, the kind of guidance is not very helpful. But but there is extra advice and guidance from the professional bodies to give that reassurance, isn't it, Emma, what you want to do as a duty holder, you want to know for yourself that they're competent, but also in law that you know you're getting the right kind of services for you to meet the duties that are upon you as those creating the risk.
Yeah.
So I could circulate that link afterwards to all the attendees.
Thank you.
Thank you for that. And then the next question, when entering an SNR in the HSE SNR calculator, should we consider deducting HSE recommended real world factor, so take off 4 from the SNR and input the result?
No, the calculator does it for you. So I'll just go back to a screen share just so you can see that, so we can be absolutely certain for absolute clarity. So what you've got is the SNR. The SNR value is the one that is given on the packaging from the manufacturer, and then the calculator does the automatic derating. Okay, you don't need to do that.
Thank you.
Okay.
Another one. In your opinion, is there any? Oh, sorry, the questions are coming in thick and fast at the moment. In your opinion, is there any further benefit of using the octave band or HML method over the SNR to select hearing protection?
I think, do you mind if I chip in on that one, Emma?
No, not at all.
I think it would depend on the kind of noise that the workers were in. So if you have people that are working in a, let me think, a woodworking factory, say, and they're using circular saws, and it's creating lots of high frequency noise, then it would be very interesting to do a full octave band analysis, establish what the level of noise was in those high frequencies, and then select hearing protection with a high H value. Yeah, so generally speaking, the more information, the better, of course.
Yeah, I'd pretty much agree with that, Mark. Sometimes it's just not practicable for people to go into the level of detail, and that's why we have the 3 different methods, so you can pick and choose for from each of those. But yeah, the more detail you have, the more information you have, and sometimes that's the way to go.
Cool, thank you. And could you go over the C-weighted input you entered into the HSE SNR, please, and why would you not use the A-weighted?
Okay, this might be a brief acoustics lesson, so hang on to your chairs, everyone. So in acoustics, you have 2 weighting curves that are primarily used when dealing with noise. So if you have a microphone, I'm going to use my pen as an example as a microphone. Here's my microphone. Microphones will generally hear all frequencies of sound exactly the same way, i.e. a flat, largely flat frequency response. Human hearing mechanism does not hear that way. The human hearing mechanism amplifies speech frequency. This is just evolution. It amplifies speech frequency and it attenuates at low frequency and high frequency. I'm currently drawing a really bad graph for you to see. So here is my graph on my scrap bit of paper. So frequency along the bottom, decibels up the side, and that's how a microphone would hear all of those different frequencies. An ear under steady state noise will hear, oh, hang on, like this curve. So we attenuate low frequency, we accentuate high frequency, speech frequency, and then we attenuate again at high frequency. And a dog whistle is somewhere over here. That's why dogs hear dog whistles and we don't, because it's outside of our hearing range. Human hearing range, 20 hertz to 20 kilohertz. However, the human hearing mechanism does also have a response to sudden impulsive noise. So if you remember, the curve I've just showed you is for steady state noise, much like factory noise. But the ear responds differently to sudden inputs. And that's the C weighting curve, and that's this one here. And it's basically a correction factor that we add to what the microphone hears in order to simulate human hearing. So when you're using the calculator, sometimes it will ask for the LAEQ, which is the time-weighted equivalent A-weighted noise level in different frequency bands. That's the steady state noise. But when you use the calculator with the SNR, you need to use the LCEQ, which is the C-weighted one. And if I just show you my graph on my scrap bit of paper again, it actually includes much more low frequency energy here. I'm doing this backwards. So that's the bit that gets included. That's your brief acoustics lesson.
I hope there's not going to be a pop quiz after this. Right, so the questions are still coming in. We've still got 5 or so minutes, so we can still get through a few more, hopefully. What is your opinion on personal molded hearing protection over standard earplugs?
Mark, do you want to go on that one?
Yeah, personal hearing protection is better generally, provided, of course, that it's made correctly, which it usually is, and provided it's inserted correctly, which it mostly is, but sometimes isn't. I think we've probably all seen people who buy universal hearing protection. foam plugs, say, or something, and their ear canals are just too small to accommodate it, and you see them with it hanging halfway out. And again, unfortunately, these people, well, they do think they're doing something, but they're not, and that's dangerous. Custom-made hearing protection is specifically moulded to the ear, and if it's made well, it will fit well, and it will provide a good level of attenuation. Clearly, they're more expensive, and there's a certain amount of inconvenience attached to getting them. You have to have impressions of your ears and so on, but long term, they're a better solution.
I'm going to come in on the back of that because from the HSE perspective, it will be a slightly different answer. But I just wanted to demonstrate the Shrek position, which you indicated there, because I happen to have some earplugs on my desk. I think this is what you were talking about, wasn't it, Mark?
It was.
Yeah, this is what we call wearing earplugs for the benefit of the HSE audience. Our view on custom moulded hearing protection, sometimes it is absolutely the right thing to have for an individual, and sometimes it isn't. They are one of many options within the wide and varied hearing protection market. And I think Mark has rightly pointed out that we have different ear canal sizes, and particularly with the much more diverse workforce that we have these days, is you'll have people that have got smaller, narrower ear canals. As a very large generalization, that would generally be the female population. But there are always going to be exceptions to the rules. You will have fellas in the workplace who've got very narrow ear canals, and they just won't fit things like these earplugs, which I've just shown you here. These are nice orange foam roll down ones. Oh, other colors are available, and they're tricky to fit. So there are definite advantages, but there's also, like Mark said, the cost-benefit analysis in terms of the investment in the workforce. If you have a high turnover of people, it might be something that isn't financially viable, and does it then fall into the reasonably practicable basket? So yeah, a slightly different perspective on that from you, Mark.
Thank you.
So.
Another one here. Overprotection is a real problem in the workplace. Do you have any perspective on how many safety incidents occur in part to being overprotected and effectively deaf to the environment, even if not listed in the primary reason of the accident?
That's a really great question. I'm just going to dive straight in there, Mark. One of the unfortunate, might not be quite the right word, the unfortunate things about noise-induced hearing loss, that it is not RID or reportable. That's the Reporting of Diseases and Dangerous Occurrences regulations, whereas hand-on vibration issues are. So in terms of finding out how much, I'll call it audibility for the sake of using a term, how much that has contributed to a workplace incident, it's very difficult for us to get actually a pin down on that. It's quite rare. We talk about noise and vibration as not being sexy subjects because noise doesn't generally kill people. However, it has massive impact on quality of life. But when it does kill somebody, and it's quite rare, it's usually to do with workplace audibility. And Mark mentioned that right early on in this session, saying if you're overprotected, you might not hear that forklift truck coming along. And on the very sort of infrequent occasions that the fatality investigations do cross our desks, that's often something that you see. But in terms of actually pinning it down to numbers, it's not something I have to hand. I could certainly go away and ask the inspectors if they have a handle on that, but it's difficult to get it because we just don't have the stats for it, to my knowledge.
Yeah, I'd agree. I think I've asked the question before as well because it's something of interest, and I know working in the construction industry, a lot of the fatalities and serious accidents were anecdotally related to audibility, because we think about workplace transport as being one of the key fatal contributors to accidents in construction. If we think about the recent, or maybe not so recent now, Network Rail fatalities, because again, people couldn't hear the signals, the train coming towards them. So I think it's difficult to get the evidence, but I would probably think it's probably greater than what we'd anticipate as a contributor to some of those serious accidents.
So I think we've got time for one more, and then there's a few more after that. Like I say, we'll email over to you if you're able to answer those, and I'll include those in the email that I'll send out with the recording. So yeah, one more if that's okay with you guys. If a person's daily noise exposure is in the LEAV below UEAV, and they show a number of measurements exposing them to levels above the UEAV peak sound pressure, would you impose HP?
Say that out loud again. I'm going to have to write some of it down.
Yeah. If a person's daily noise exposure is in the LEAV, and then in brackets below UEAV, and they show a number of measurements exposing them to levels above the UEAV peak sound pressure, would you impose HP, which I assume here is hearing protection? Hearing
protection. Yeah, they're exceeding the upper exposure action value, so measures need to be put in place. Yeah.
Nice simple answer to a much longer question.
So that was just for the peak, was it? So the kind of daily average exposure is between 80 and 85. Yeah. But their peak exposure is above the peak, so they have protection for that peak. And would that be, is me asking a question, would that be a specific type of hearing protection just for that peak exposure?
It could quite possibly, if it's predictable peaks, then possibly, and we're going into quite some depth here. If it's unpredictable peaks, then it might be a different type of hearing protector. You can get ones that have got clever electronic circuitry in them that will amplify background noise or amplify the general environment, so you can still hear what's going on, but when there's a peak that kicks in, it will just reduce that peak. And it's through, if anybody's familiar with sound engineering and sound recording, it's some kind of compression that's used. I don't know the electronics about it, but that's what they generally do. Sound restoration or level dependent hearing protection, I believe it's called.
Nathan, thank you for that. Well, unless, do you feel like you've got time for a few more, or would you rather them email the cross? I can leave that to you.
I'm okay to hang around. I don't know about others, but I'm also aware that we may lose people off the webinar as well.
Yeah, in that case, yeah, there's a few more questions. There's another 6 questions that have come in. So in that case, I will say that we'll call the webinar there then. And like I say, I will email them over to you, so you've got a bit of time to answer each question. And thank you for all the questions. I've really enjoyed the level of engagement we get with these webinars so far. So thank you for that. And I will say thank you to Emma and Mark for your presentation today, and thank you, Claire, as always, for helping out and everything. And as Claire mentioned, we've got the next one in 2 weeks' time on a Thursday, 2 till 3 again, and emails to register for that will go out next week, so keep an eye out for that. So thank you once again, and we shall speak to you all very soon.
Yeah, thanks to you both. Thank you very much.